Hey everybody, welcome to semester 2, day 5 of summer school geometry. Today we're going to be talking about a perimeter and area of various geometric shapes and how their linear dimensions affect those two things, the perimeter and the area. So just as a review from yesterday, day 4, yesterday we talked about circles and just going to review that real quick. So since we're talking about area and perimeter, first of all, the area of a circle is pi r squared, where the radius is this length right here from the center out to the edge. And the perimeter of a circle, so I'll put p, we also call that in this case of a circle, it's called a circumference, but in general we can say that's the perimeter as well, is 2 pi r, 2 pi times the r. And there are more videos out there. I won't get too deep into why these are the formulas, but there are more videos out there that show you why these types of equations are true, why these formulas hold true. So you can look deeper into that on your own. For a triangle, the area is going to be 1/2 base times height, and the base is the bottom of the triangle. So if it's oriented like this would be the base. And the height is, if I draw a straight line going down from the top that's perpendicular to the base, that's called the height. So be very careful in triangles, is the height is a line that goes straight up and down. So it's not going to be this line right here. That's not the height. That's actually called the slant height because it's kind of slanted. The height itself, or the altitude, is this line right here. And then for the perimeter, of course, for the perimeter, you just add up all three sides. So this is just a general triangle. You need to figure out in each problem what the lengths of the sides are of a triangle, and that's how you get the perimeter. For a parallelogram, the area is just base times height, just like a rectangle. A parallelogram is very similar to a rectangle because it has four sides, and all four, the two sets of sides are parallel to each other. But in this case, to find the area, you would use the base over here, this bottom part, just like the triangle. And then the height, just like the triangle, is the vertical distance between the top and the bottom. And that's called the height. And then the perimeter would be all four sides, side lengths added up together. And for a trapezoid, this is a bit more of an interesting formula. There are ways you can derive it. In general, the area of a trapezoid is going to be 1/2 base 1 plus base 2 times the height. So when you're thinking about what base 1 and base 2 are, the definition of a trapezoid is any shape, four-sided shape, that has two parallel sides. The other two sides, however, are not parallel to each other. So that's the difference. A parallelogram, both sets of sides are parallel. A trapezoid, only one set of sides is parallel like this. The other two are not. So in this case, base 1 is actually going to be one of those two sides, and base 2 is the other one. So base 1, I usually like to make that the shorter side, and base 2, I make the longer parallel side. And the height, still just like all the other ones, is this length right here. Okay, so there's the area for trapezoid. And then the perimeter of all these different shapes is the sides added up. So in Delta Math, the problems will throw you different shapes that are composite shapes. Now, a composite shape has many other shapes within the picture itself. It's composed of various different shapes. So like in this example, you can think of it in two different ways. If we're trying to find the area, the entire thing looks like a trapezoid. It is. Or you can think of this as a triangle, a rectangle, and another triangle. So you could apply either formula, just the triangle, the rectangle, and another triangle, and add those up. Or you can use the formula for an entire trapezoid here. And so I like to do less work and make it kind of easier for myself. So if you look right here with our trapezoid formula for area, we know that that's going to be 1/2 base 1 plus base 2 times the height. So like I said earlier, the base 1, I usually like to make the short side. So I'm going to say that this is base 1, and then this entire thing up here, all the way from either side to either corner to the other one, that's going to be base 2. And height is going to be 6.4. So now let's just plug in, and then you simplify after that. So area is going to be equal to 1/2 6.7 plus, now base 2 is this entire length right here. Look at what it gives us. It gives 12.5 up until here, and then 6.5 the rest of the way. So 12.5 plus 6.5 is going to be 19 times the height we said was 6.4. So we get 82.24 right here. And that's the area of this trapezoid. Now what we could have done, you could have taken these two triangles, figured out their areas, and then done the area of this rectangle and added all three up. You would still get the same thing here. Okay, let's try another example, another composite figure. This one says to find the area of the figure below. It has a rectangle and two semicircles. A semicircle is half of a circle, semi meaning half. So you see these two half circles out here. And then I got the rectangle within here. So if I wanted to kind of think about, just first of all, let's start simple. The area of the rectangle in the middle. So I'm going to shade all of that in. It's going to be base times height. So that's 9 times 8, which is equal to 72. But then I also need to include what's the area of this circle, semicircle, and this other semicircle. So I need to first think, what do I know about the area of a circle? Well, the area of a circle, in general, a circle is going to be area equals pi r squared. But now I just have half of it, half of a circle. So that's going to be 1/2 pi r squared, half of it. Same thing over here, 1/2 pi r squared. So now let's look closely at our picture and think about what the radius is. So if I know that this side of the rectangle is 8, it's also the diameter of the circle. Since this is a semicircle, this is the diameter, 8. So halfway would have to be 4. The radius is 4. So I'll put r equals 4 right here, just like that. So now I know that the area is 1/2 pi times 4 squared, which is equal to 1/2 pi times 16. And then 1/2 times 16 is equal to 8 pi. So that's this guy right here. This is 8 equal to 8 pi. And this is the same exact semicircle, so I don't need to do the work again. It's the same exact thing, 8 pi. There you go. So now I just need to add all of these up together. So the area of the entire shape with the two semicircles and the rectangle is going to be 8 pi plus 72 plus 8 pi. And those are these three numbers right here. All three shapes combined. And the question asks us to round the answer to the nearest tenths place. So let me pull up my calculator and let's figure this one out and round it to the nearest tenths place. Okay, I rounded it to the nearest tenths place, 122.3. Okay, let's try the last example on the back, last two examples. It says find the perimeter. Both of these examples are the perimeter now. We got a parallelogram here, and we have this semicircle like this. It's kind of a weird shape, but we could figure out the perimeter. So if I think about what the missing sides are, I need the sides now. Since this is a parallelogram, the opposite sides are the same length. This is 12 and 12. And this opposite side is going to be 10. But now 10 is not the outside. The 10 is just helping me figure out the semicircle. Half of it is the radius, which is 5. And to figure out the perimeter of this semicircle, I know that in general, the whole circle, the circumference or the perimeter is equal to 2 pi r. So that means that this semicircle has to be half of that circumference. So 2 divided into halves is just 1 pi r. So I'm going to point to that and say that that length is pi times r. The blue line, semicircle, pi times r. So that makes that equal to 5 times pi. So now I just need to add up 12 plus 10 plus 12 plus 5 pi. And once again, we need to round to the nearest tenths place. So I get that the perimeter is 10 plus 12 plus 12 plus 5 pi. Okay, so let's go ahead and add all that up. So we get that that's equal to 49.707, which we round to just be 49.7. And we'll put those rounded signs right there. All right, last problem here, find the perimeter of the figure below. Okay, we've got this line is the left side over here. Now it's also a semicircle, it's just coming into the shape, that's okay. It's still a semicircle. So this guy right here, just like we saw before, is pi r. And if I look over here at this end, we also have another half circle circumference, pi r. And this guy right here is 15. So this down here has to also be 15. Now I know that the radius of the semicircle here is 5. So if I wanted to figure out now, pi times the radius is 5 pi. Same thing over here, 5 times pi. Okay, so I have 5 pi, another 5 pi, and then 15 plus 15. So here we're going to have that the perimeter is equal to 15 plus 15 plus 5 pi plus 5 pi. And now we just simplify all of that. 15 plus 15 plus 5 pi plus 5 pi. We get 61.415. 61.415. And we need to round it, so we get 61.4. Okay, so there's some examples for this week. Go ahead and go back to Canvas, check out your assignments. You can log into Delta Math and complete the problems. Please email me if you have any questions. My email is right here, or you can message me on Canvas if you have any questions.